Good morning friends, welcome back to Parnika tutorials. In the last few videos, I have discussed two process synchronization mechanisms such as lock variable, test and set instructions. I hope you have watched those two videos. If you did not watch those videos or if you don't know that concept, I request you to go back and watch those videos and come back to this video. In this video, I want to discuss one more process synchronization mechanism which is a turn variable or strict alteration mechanism. So I request everyone to watch the complete video for better understanding. First, I will discuss the working process of turn variable. Then I will discuss its limitations. Look at the few important points related to the turn variable. It is a software mechanism. We already discussed about the lock variable. It is also a software mechanism. But test and set instruction is a hardware mechanism. And we have two modes. One is the kernel mode and another one is user mode. If it is a kernel mode, then the mechanism takes the support from the operating system. If it is a user mode, then the process synchronization mechanism does not take any support from the operating system. So turn variable runs in the user mode. And we have two types of synchronization mechanism. One is the busy waiting and another one is non-busy waiting. The turn variable comes in the category called busy waiting, and this mechanism only works for the two process. Either it can be process P0 comma process P1, or you can say Pi comma Pj. Is it clear? It will works only for two process, and we will have a variable called turn. Okay, if turn is equal to 0, then meaning is that process P0 can enter into the critical session. If turn is equal to 1, process P1 can enter into the critical session. Is it clear for you? Now look at here. Let's take the turn is equal to 0, then meaning is that process P0 can enter into the critical session. And if you look at here, any process synchronization mechanism, we will have the entry session, critical session, then exit session. So this is the entry session for the process P0 and exit session. And coming to the process P1, this is the entry session and exit session. Now look at here. While turn not equal to 0, what is the turn value? 0. 0 not equal to 0. So this condition is false. If this condition is false, process P0 will enter into the critical session. So you have a critical session. Process P0 will enter into the critical session. And then look at here. Turn is equal to 1. Let's consider that process P0 is there in the critical session. Now I want to check whether this solution is providing the mutual exclusion or not. Meaning is that when one process is there in the critical session, then another process should not enter into the critical session. At max, only one process should be there in the critical session. If it is there, then we will say that it is a mutual exclusion. Now check it. When the process P0 is in the critical session, whether this turn variable concept is allowing the process P1 to enter into the critical session or not. Now turn value is equal to 0, while turn not equal to 1. 0 not equal to 1. Whether it is true or false? True. Is it clear? So the condition is true. If the condition is true, again it will check the condition only. Is it clear? It is false in the loop. Whenever the condition is false, then only it will enter into the critical session. As the condition is true, again it will keep on checking the condition only. So that's why we will call it as a busy waiting solution. Is it clear? So it is not allowing the process P1 to enter into the critical session. So I can say that mutual exclusion is provided. Is it clear? Now we will discuss the complete solution. Now look at here. Now process P0 is there in the critical session. When it exits from the critical session, it will make the turn value is equal to 1. Okay, if turn value is equal to 1, meaning is that process P1 can enter into the critical session. Now look at here. While turn not equal to 1, 1 not equal to 1, the condition is false. If this condition is false, then process P1 can enter into the critical session. Is it clear? Now we will see when the process P1 is in the critical session, can this turn variable concept will allow the process P0 to enter into the critical session or not. Now turn value is equal to 1. So look at the entry part of the process P naught. While turn not equal to 0, 1 not equal to 0. So this condition is true. If this condition is true, again it will check the condition only. It falls in an infinite loop. So that's why it is called as busy waiting. So in both the scenarios, the mutual exclusion is provided. Okay, are you able to understand? When the process P1 exit from the critical session, it will make the turn value is equal to 0. So when process P0 enter into the critical session and leave the critical session, it is giving the turn to another process. Is it clear? Now we will check whether progress is achieved or not, because we have two primary requirements for any process synchronization mechanism. One is mutual exclusion and another one is progress. So we will check whether this turn variable process synchronization mechanism achieves the progress or not. What is meant by progress? As it is a two process solution, we have P0, P1. Now, when P0 is not ready to enter into the critical session, it should not stop the process P1 to enter into the critical session. If process P0 is not ready to enter into the critical session, it should allow the process P1 to enter into the critical session. If it allows, then we will say that it is a progress. Similarly, when process P1 is not ready to enter into the critical session, it should allow the process P0 to enter into the critical session. Is it clear? Because at a time, only one process should be there in the critical session. When P1 is not ready to go to the critical session, it should allow the P0 to enter into the critical session. If it allows, then we will say that progress is achieved. Now we will see whether it is achieved or not. Let's consider that turn value is equal to 0. If turn value is equal to 0, who is allowed to enter into the critical session? Process P0. Now let's take that process P0 is executing the non-critical session. We know that any process, two process, if they are cooperative process, then we will have the non-critical session, entry session, critical session, exit, then again we will have non-critical session, and we will have the critical session like this, because before any critical session we will have the entry session, after the critical session we will have the exit session. What I want to say here is that if two processes are cooperative process, we will have the non-critical session code, critical session code, non-critical session, like that we will have. Am I right or wrong? Let's take that turn value is equal to 0. Process P0 is executing the non-critical session. If it is executing the non-critical session, it is not ready to enter into the critical session. If process P0 is not ready to enter into the critical session, it should allow the process P1 to enter into the critical session. If it allows, progress is achieved. Now let's check it whether it allows the process P1 to enter into the critical session. Now turn value is equal to 0. If process P1 wants to enter into the critical session, it should execute the entry session. Now what is the entry session? While turn not equal to 1. What is the turn value? 0. 0 not equal to 1. The condition is true. Am I right? 0 not equal to 1. The condition is true. If the condition is true, it will again check the condition. It falls in the infinite loop. Whenever this condition is false, then only it will execute the critical session. As the condition is true, it will keep on executing the condition. So it is in busy waiting. So if it is in busy waiting, is the process P1 is entered into the critical session? No. So when process P0 is not ready to enter into the critical session, it is not allowing the process P1 to enter into the critical session. Now we will see another scenario. Let's take the turn value is equal to 1. If turn value is equal to 1, who can enter into the critical session? Process P1 can enter into the critical session. Now look at here. P1 is executing the non-critical session, meaning is that it is not ready to enter into the critical session. Let's see whether it allows the process P1 to enter into the critical session or not. Look at the entry session of process P0. Turn not equal to 0. 1 not equal to 0. The condition is true. If the condition is true, again it will check the condition. It is fallen in the infinite loop. So process P0 is not entering into the critical session. When process P1 is not ready to enter into critical session, it is not allowing the process P0 to enter into the critical session. So I can say that progress is not achieved, which is one of the important requirement for any process synchronization mechanism. So it is achieving the mutual exclusion, however it is not achieving the progress. Okay, now we will see the secondary requirements of any process synchronization mechanism. The secondary requirements are bounded weight and then architecture neutrality or the portability. Is it clear? Now we will see whether bounded weight is achieved or not. Look at here, what is meant by bounded weight? When process P0 is there in the critical session, how much time the process P1 should wait? Whether it is going for the starvation or not, we will check it. Is it clear? Now look at here. When turn value is equal to 0, process P0 can enter into the critical session. Let's take that process P0 is there in the critical session. Now, once it exits from the critical session, turn value will become 1. If turn value will become 1, who can enter into the critical session? Process P1 can only enter into the critical session. Similarly, when process P1 is there in the critical session, when it leaves the critical session, it will make the turn value is equal to 0. If turn is equal to 0, who can enter into the critical session? Process P0 can only enter into the critical session. Meaning is that once the process P0 completes the critical session, it will give the chance to process P1. Similarly, when process P1 completes executing the critical session, it will give chance to the P0. So after this it will work, after this one will work. So there is a bounded weight, there is no starvation or the deadlock. And architecture neutrality, as it is a software mechanism, it can be work in all the operating systems. So I can say that architecture neutrality also achieved. Only progress we cannot achieve using the turn variable or strict alteration mechanism. So this is the limitation of the turn variable. I hope you have understood what is the turn variable, what are the interesting points related to turn variable and its limitations. If you still have any doubts related to this process synchronization mechanism, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.